Alright, so we are told a car traveling 95 kilometers per hour strikes a tree. The front end of the car compresses and the driver comes to rest after traveling 0.9 meters. What was the magnitude of the average acceleration of the driver during the collision? And express your answer in terms of g, where 1g equals 9.8 meters per second squared. So first things first, we're going to write out the constants. So v naught equals 95 kilometers per hour. Now let's put that into meters per second real quick. So 1 kilometer, 1,000 meters, times 1 hour, 60 minutes, times 1 minute, over 60 seconds. This is going to equal, so 95 times 1,000 times 1 times 1 divided by 60 times 60. So it's going to be 26.39 meters per second. V final equals 0 meters per second because we end at rest. And the delta x equals 0.9 meters. Now we have three constants, so we can actually use one of our equations. So let's say 2a delta x equals v final squared minus v initial squared. So we're looking for a, so let's say 2 times a, delta x 0.9, v final is 0, so it's going to be 0 squared, cross that out, minus 26.39 squared. Let's do some math. 20, so we'll square it. Then we'll divide by 2. Then divide by 0.9. So we'll get acceleration equals negative, don't forget the negative right here, 386.87 meters per second squared. So now what we have to do, we have to put it in terms of g's. So we know that 1g equals 9.8 meters per second squared. So if we want to convert this to meters per second squared, or g's, we can just divide it into g's. So we can say this many, or this much deceleration, if we divide it by 9.8, we'll get how many g's we're actually experiencing. Because 1g is just like your daily, everyday gravity that you experience. But when you're decelerating a lot, you experience several g's. So that's why we're dividing it. So this is going to give us 39.48 g's. And that is our final answer.